There is a question that philosophers have asked for thousands of years, long before telescopes existed, long before we had mathematics sophisticated enough to describe the shape of space. The question is simple. It has never been fully answered. How big can something get? Not in the abstract, not as a thought experiment, in reality, in the actual physical universe governed by actual physical laws. Is there a ceiling on size? Is there a point at which the cosmos says no further? Is there a largest thing? We may have found it. And the moment you truly understand what it is, the question stops feeling philosophical. It starts feeling personal. It starts feeling like the ground beneath everything you thought you understood about scale and existence has quietly been removed. Its name is Phoenix A star. It sits at the center of the Phoenix cluster, one of the most massive galaxy clusters ever discovered, approximately 5-7 billion light-years from Earth. And it is, by every measurement we currently possess, the largest single object in the observable universe. Not the largest star, not the largest galaxy, the largest black hole. Its mass is estimated at 100 billion suns. Some models push that figure toward 150 billion. Let that land for a moment before we move on, because the number alone does not do the damage, the comparison does. The black hole at the center of our own galaxy, Sagittarius A star, has a mass of 4 million suns. We spent decades proving it existed. We won a Nobel Prize for it. It is the gravitational anchor of a galaxy containing 400 billion stars. We orbit it. Everything in the Milky Way orbits it. It is, by any ordinary human standard, incomprehensibly large. Phoenix A star is 100 billion solar masses. That means it is roughly 25,000 times more massive than the object that holds our entire galaxy together. If Sagittarius A star is a city, Phoenix A star is a continent. If Sagittarius A star is a mountain, Phoenix A star is a planet. The comparison does not just reveal a difference in size. It reveals that our intuitive sense of what large means was built on a sample too small to be trusted. Its event horizon, the spherical boundary beyond which nothing returns, spans approximately 590 billion kilometers in diameter. The distance from Earth to the Sun is 150 million kilometers. The event horizon of Phoenix A star is nearly 4,000 times that distance across. Our entire solar system, every planet, every moon, every asteroid and comet and scattered debris field from the Sun all the way out to the theoretical edge of the Oort cloud. All of it would fit inside the event horizon of Phoenix A star, with the kind of room that makes the comparison feel almost absurd. You would not need to fall into Phoenix A star to be destroyed by it. Long before you reach the event horizon, tidal forces, the difference in gravitational pull between the side of your body facing the black hole and the side facing away, would stretch you along the direction of infall and compress you perpendicular to it. Physicists call this process spaghettification. It is an almost comically inadequate word for the experience of being atomically disassembled by the curvature of spacetime. But here is something that most people do not consider about a black hole of this particular scale. The tidal forces near the event horizon of a very large black hole are actually weaker than those near a smaller one. This is because the event horizon of a massive black hole is so far from the singularity at the center that gravity, while overwhelming in absolute terms, does not vary as dramatically across the scale of a human body at that distance. A person falling through the event horizon of Phoenix A star would not immediately feel the tidal forces that would destroy them near the event horizon of a stellar mass black hole. They might, in the final moments of crossing, feel almost nothing unusual. The stars around them would begin to appear distorted, blue-shifted ahead and red-shifted behind, the universe rearranging itself optically as curved spacetime bent the paths of incoming light. But the physical sensation of crossing might be subtle, quiet even, and then they would be inside, in a region of spacetime from which no information can escape, from which no signal can be sent, in which the future, in the language of general relativity, points not forward in time, but inward toward the singularity. You cannot avoid the center of a black hole once you have crossed the event horizon for the same reason you cannot avoid tomorrow. It is not in space, it is in time. The singularity is not a place you travel to. It is a moment you arrive at. What waits at that moment our physics cannot say. Now step back from the interior. Step back from the event horizon. Step back far enough to see Phoenix A star in its cosmic context, because the object itself is only part of what makes this discovery philosophically staggering. Phoenix A star sits at the center of the Phoenix cluster. A galaxy cluster is not a grouping of stars. It is a grouping of galaxies, each galaxy containing hundreds of billions of stars, each galaxy separated from the next by millions of light years of mostly empty space. The Phoenix cluster contains hundreds of galaxies. It is one of the most massive gravitationally bound structures in the known universe, a superstructure so large that light crossing it would take hundreds of millions of years to complete the journey. And at the center of all of it, anchoring the entire system, pulling everything into a slow gravitational relationship that will persist for billions of years, is Phoenix A star. This is where philosophy and physics begin to converge in a way that neither discipline can fully contain on its own. The ancient question was whether everything exists in hierarchy, whether there is always something larger, always something smaller, an infinite regress in both directions with no floor and no ceiling. The philosophers who believed the universe was infinite in scale argued that no matter how large something was, you could always conceive of something larger. The universe would always accommodate more. Phoenix A star does not disprove this philosophically, but it does something more immediate and more unsettling. It reveals the ceiling of what the present universe, operating under present physical laws with present cosmic history, has actually managed to produce. It is not a theoretical limit. It is an empirical one, the largest thing we have found. The largest thing that the 13.8 billion years of cosmic evolution available to us has, so far, assembled. And it assembled it from violence. Black holes of this scale do not grow gently. They grow through consumption and mergers, swallowing gas, capturing stars, absorbing the remnants of smaller black holes when galaxies collide. The Phoenix cluster, being as massive as it is, would have been the site of extraordinary galactic activity in its history. Multiple large galaxies merging over billions of years. Multiple central black holes spiraling toward each other, radiating gravitational waves that rippled through spacetime across cosmic distances, ultimately merging into something larger than either progenitor. Then that merged object consuming more, growing more, becoming what we now measure. Phoenix A star is not just a large thing. It is a record of everything the universe did to create it. Every galaxy that merged, every star that was consumed, every smaller black hole that was absorbed. Its mass is a history written in gravity, and we are reading that history from 5-7 billion light years away through the limited instruments of a civilization that only understood black holes existed at all within the last century. There is a humility required by this that is difficult to sit with. We discovered black holes theoretically before we confirmed them observationally. We predicted them from mathematics, from the equations of general relativity published by Einstein in 1915. Equations which implied that if enough mass was concentrated in a small enough region, spacetime itself would close around it and nothing could escape. For decades, many physicists resisted the implication. Einstein himself was uncomfortable with it. The idea that the universe could produce regions of infinite density, points where the laws of physics as we knew them ceased to apply, seemed like a flaw in the theory rather than a prediction to be taken seriously. The universe did not share their discomfort. It had been making black holes for billions of years before we arrived to theorize about them. It made stellar mass black holes from dying stars. It made intermediate mass black holes from processes we still do not fully understand. It made supermassive black holes at the centers of galaxies through mergers and consumption across billions of years. And somewhere in the Phoenix cluster, through a sequence of mergers and consumption events on a scale unprecedented in the observable universe, it made Phoenix a star, 100 billion solar masses, sitting quietly, holding a galaxy cluster together, doing what black holes do, warping spacetime around them, shaping the evolution of everything nearby, existing with the particular indifference of something that has not needed to justify itself to anyone. The philosopher in you wants to ask what it means, whether size implies significance, whether the largest thing in the observable universe occupies a special position in whatever meaning structure you use to navigate existence. The physicist in you knows that Phoenix A star does not know it is large. It does not experience its own scale. It does not know it is the record holder. It simply is what it is, a solution to the equations of general relativity, a region of spacetime with particular properties, an object that will continue to exist long after the stars around it have burned out, long after the galaxies it anchors have evolved beyond recognition, long after the universe has cooled and dimmed into the long darkness that thermodynamics promises awaits everything eventually. In the far future, trillions of years from now, in timescales that make the current age of the universe feel like the opening second of a long film, even Phoenix A star will end. Through a process called Hawking radiation, black holes slowly emit energy over astronomical timescales. The more massive the black hole, the slower the evaporation. A black hole of Phoenix A star's mass would take something on the order of 10 to the power of 100 years to fully evaporate. A number so large it has no meaningful comparison in human experience. But the process is real. The endpoint is the same. Eventually, imperceptibly slowly, Phoenix A star will return its mass to the universe in the form of radiation. The largest thing that has ever existed will become light. There is something in that arc, from the violence of galactic mergers, through the silent dominance of 100 billion solar masses, to the slow, patient dissolution back into energy, that feels like it is trying to tell us something. About impermanence, about the relationship between scale and duration, about what the universe ultimately does with everything it builds. It builds it, it holds it, and then, across timescales that no mind can truly inhabit, it takes it apart. We are 5-7 billion light-years from Phoenix A star. The light we observe from it today is 5-7 billion years old, older than the Earth itself. We are not seeing Phoenix A star as it is. We are seeing it as it was before our planet existed, before our sun had completed its formation, in a universe that did not yet contain a single human thought. Whatever Phoenix A star is right now, in the present moment of the universe, we cannot know. It may have grown. It may have quieted. The galaxy cluster around it may have evolved in ways we cannot predict from here. We are looking at a message sent before we existed, from the largest object the universe has produced, traveling across billions of light years of expanding space to reach us. And what we receive when we decode that message carefully is not comfort. It is not terror either. It is something older and quieter than both. It is perspective, the kind that only comes from understanding, truly understanding, how large the universe is, how small we are inside it, and how extraordinary it is that we are here at all, small enough to be humbled, curious enough to look, and aware enough to know what we are looking at. Phoenix A star does not need us to exist. It does not need us to measure it or name it or make videos about it. It was the largest thing in the universe long before we were anything at all. But we looked, and in looking, we became something the universe had not produced before, something that could be astonished by its own home. Subscribe, because the largest thing in existence is waiting to be understood. And we have barely started asking the right questions.